everyone. Thank you for coming along here on a fairly sunny but blowy Monday evening. Apologies if we've confused you by having a meeting on a Monday rather than normally it's a Thursday. Maybe that's confused people, but thank you so much for coming along anyway. And thank you for those who are here online as well. So that's great to have some online presence. It's really good. We've got Joe here in person, but before we go into Joe's talk, I'm just going to give Sam here a chance to come and tell us a little bit about an event that's happening later on this week from the OWASP group.
Sure. Hi, everyone. My name is Sam Stepanian. I'm one of the leaders of OWASP London chapter. We do have an event this Thursday, which will be happening at the same time from 6:30. Doors open at 6. It will be happening at Thought Machine offices. For those who don't know, this is a startup which is based in the ex-Mercedes garage, which is next to the Russell Square tube. So you can join us on Meetup as well as on Eventbrite. Just Google for OWASP London. We're going to have 2 speakers. First speaker is going to talk about software supply chain security challenges, and the second speaker will be talking about use of AI for threat detection and the exploitability scores improvement. So
great.
Yeah.
And for those who might not have heard of OWASP before, do you want to just explain who OWASP is?
Yeah, OWASP is a worldwide non-profit corporation. So we are Open Worldwide Application Security Project. So we are a non-profit, which mission is to make sure that the world knows how to fix software security problems and educates everyone on the software security. We operate through worldwide conferences, so we run 3 global conferences a year, 1 in Europe, 1 in Asia, and 1 in America. We just had our European conference in Barcelona a couple of weeks ago. And also we have quite a large community operating through local chapters worldwide. We have over 200 chapters in every major city all around the world, and also through projects. On all our projects and tools, standards, guidelines, they're all free and open source, available everyone to use.
That's great. Thank you very much. And if you haven't come across OWASP before, do take a look. There's some really helpful resources there for people to top up their training background and do some real work as well.
Yeah. And I presented here as well. So it's actually a recording of
absolutely. So as Sam says, so if you want, you can go and look back at one of the past BCS DevSecOps groups meetings. Sam's given a great introduction to the resources and a real sort of whistle-stop tour of all those assets there. So they are really valuable. So thank you for that. So the BCS DevSecOps group, so we are part of the British Computer Society, one of the special interest groups, and we sit in this sort of world in between sort of the security folk and the developers, and we're trying to help make sure that both sides understand each other's pressures, and objectives. And so one of the things that we're looking at is how automation can help, which is why particularly I've asked Joe here to come along and tell us a little bit about how automation helps in doing things in terms of deployment and all of those other things, which are really important, especially when you want to do things accurately, because doing things manually, as we know, can be fun, but it's not the most effective and so forth. And so when you've got large scale organizations, as many of us are involved with, automation is really important. So thank you for coming along, Joe. So Joe's here from Greenpeace. He'll tell us a little bit about himself and what he's up to and what his team do in a minute. But thanks very much. Okay.
Good evening. Thank you for coming. I will have to refer to my notes every so often. But yes, Ops Dev deliberately, because we, and the side that I come from, is the operations team, not developers, as became abundantly clear later on.
No, that's good.
And basically, this is how we got from, literally, what is Git, to a continuous deployment of our infrastructure and code. Now it decides not to work. Let's leave it to record it. Okay.
You might want to push the button first and see if it wakes up
Okay.
on the keyboard.
Push it.
I think it's lost its focus, hasn't it?
Yeah.
Yeah.
Okay. There we go.
Yes.
Okay, so my name is Joe Giddings. I work at Greenpeace International. I'll explain a bit more about what Greenpeace International is. I've worked there for over 25 years now. So I started out as the IT support person. I got into backends, I got into communications, I got into network, and I got into a lot of trouble because I was also a Greenpeace activist for 20 years. My speciality is boats. So I was a boat driver for about 20 years for the Little Ribs. So I've been at the intersection of civil disobedience, computers, and large governments and corporations who don't like me. And I've also had a lot of fun doing it. So Greenpeace Network. Greenpeace is a federated network. What does that mean? Herding cats. What it means is each is a legally independent entity. So I used to work for Greenpeace UK, and then I now work for Greenpeace International. What that means is each of these officers is independent. That's done for a very, very specific reason, because we work in the civil disobedience, breaking the law. We need to firewall and insulate each office. What you probably don't see now is that we used to have an office in Russia. We don't anymore because Russia declared Greenpeace an illegal organization, and therefore we had to shut it down. We had to get people out, we had to do all sorts of things, but that's a very different story. We also, the team that I work in particularly, which is the site reliability engineering, which used to be the operations team, we're also responsible for the IT on our 3 ships. So we're responsible for all of the overarching infrastructural thing that glues the whole organization together. So imagine us as the biodegradable bit that holds your recyclable cans together. That's us. This is the particular team that I work with, which used to be the operations team, but is now the site reliability engineering team. We are deliberately geo-dispersed. We do cover pretty much all of the offices in time zones, which means that the team has Philippines, China, Kenya, France, Netherlands, Europe, Brazil, Argentina, and the US. That team is within the global IT department. And if we put that on the map, we'd have even more countries, Canada, New Zealand, various other places, Sweden, Norway. So we are geographically dispersed. A lot of us have worked from home. We go into the office occasionally. I was in the office this morning before I came here, but normally I'll work from home. So why did we change from an operations team to an ops dev SRE team? We had several problems that we were trying to solve in various ways. Cost control. We had a data center in Haarlem, which is in the Netherlands, run on renewable electricity. We had a lot of machines and systems that were very hard to move. They were old. Sometimes the people who'd put them up had gone. It hadn't been done to a standard. They'd been put in. So it had a lot of technical debt. We literally had no consistency. Everything was put in whichever way it came out till it worked. Because of that geographical dispersed team, knowledge sharing was quite hard. So we had people who knew certain systems and other people who didn't. We also wanted to democratize access, which is a very posh way of saying getting more people to do our job. Because quite frankly, a lot of the stuff, if set up correctly, doesn't need to be done by an operations engineer. This is changing a DNS record, things like that. really that can be done by web people or whoever needs to do it. The benefit of that is increased time to resolution. If you get a ticket and that ticket has to go through 3 different sets of people before it gets to an operations person, and that first person could have done it, you can get much quicker. And then we take one of our aims is to get to the point where actually the web people can do it, or whoever. So those were sort of the ideas that we were trying to solve with what we did. Also, IT has changed. So IT used to be, you do an IT project, and that would get you up to the step. So project 1, you then sort of be at step project 2, and you'd be on there for like a while, and then you do another project, and up you go, and then another project. However, IT is now a constant change. So how do you get from this step project mentality to constant change? This is where you go back to school and remember your calculus. Yes. Calculus, how do you find the area under a curve? You take and draw little blocks, yeah? And the whole point of calculus is you just keep drawing smaller and smaller and smaller blocks, and you get a much more accurate area under the curve. Apply that to our change mentality. Smaller and smaller and smaller changes allow you to do things faster and quicker and change the way you think about pushing out new stuff. So, version 0, what's going to solve this thing? And how did we do it? Infrastructure as code. Yay! Solve all our problems. Didn't really know exactly what that meant. Well, we had an idea, but you know, we'd heard that someone talk about infrastructure as code as being a way to deploy stuff. Okay, well, we'll take infrastructure as code and then we'll throw it at the Git. And then we'll do some automation on it. Wasn't quite sure what that automation meant, but you know, let's have a go. So what we found out, so now I'm going to take you through a whirlwind tour of basically about start to finish 3 years, I would say, this took us. And that's from physical data center to everything in the cloud under automation that we own and deal with. So it's a classic, really, and I don't think this comes as any surprise. It's about people, it's about the processes, and lastly, it's about the technology. And quite frankly, the technology doesn't matter. It's those first 2 where actually that's what matters. So people. As I say, right. So I got this stuff running in a sort of roughly way. And I went to one of our engineers and said, okay, well, what's your Git client? To which they replied, what, Git? Greenpeace IT? No. Are you insulting me? No. This is my first sort of paradigm shift. Operations people don't necessarily know anything about code or coding. They can write scripts, bash shells, Perl shells, stuff that you couldn't read, or you need an archaeologist to come in and sort of work out because they've been writing Perl for 20 years. But they don't know how to do actual coding in terms of using a repository, version control. What's the version control? They have about 27 backup copies, which they work through by the date. Yeah. So this was the first thing is, okay, well, okay. Then we got to pipelines. And in my business, that means something totally different. So we had one group of people, so about 6 people, actually using anything that resembled an actual pipeline, Circle CI. I'd spent, and part of the reason why I was given this project was I'd spent about 3 years working with Jenkins. So I had some understanding of pipelines and versioning and what it could do. So we literally had to go back and think about, okay, what does this team do? Literally, what does it do? We're going to bring in these new bits of technology. Who's going to own them? Training. What training do we actually have to give these people who are really good, really high-level engineers? I mean, if you put one of those on a boat and said, wire up the DAC to the radio mast to get a satellite feed, no problem. As long as they got tools and things, they're quite happy. So we had to then sort of, what are people's skill sets? We went with this idea of the T-shaped person. I don't know if you've come across that as a way, which is you have a broad range of knowledge, but you're very deep in one specific area. And so what we had is a lot of L-shaped people to start with. You know, they were very deep in one, had a little bit of knowledge about some other, but not across all of the different things. So there was a lot of thought about education. I mean, this is even before we've got to serverless Kubernetes clusters, the whole cloudy thing out there. So this took us quite a while. So the first thing we had to do is actually sort of write down what is the responsibilities of this team. And it's a very good Medium article, The Road to SRE. So we borrowed that and came up with ours, which was the SAAS. You can see me Googling around letters to make something that was actually an acronym that made sense. So we were responsible for security, availability, response, observability, delivery, and self-service. That's what we set out as this team remit. So then we basically had to look at our people. So we also had to look through, when we did this, one of the things that we came across was there's lots of stuff we were doing that didn't really fit. So we were fortunate we were able to take these to the upper management and say, look, there's this stuff is actually data work that we've been doing here. And this bit over here is sort of an application. It's not really what we as a team are looking after. So this was also the catalyst for bringing up two other teams, actual development team and a data team. So from that, we were able to get rid of some of those bits and pieces over time. But still, this is all of the responsibilities of the operations team. And we had to try and put this, again, into a way to understand who did what. Not only who did what, in what time zone did they do it, and how good were they at it. This is all self-scored, by the way. So this is actually how the engineers saw themselves at the start of this process. So the idea is to get a good coverage of each of those in every time zone. So Windows, identity, observability, security, infrastructure, data. And so this is still all of the different sort of roles and work that we look after. And then we had to make training. So I have a whole slide deck, which is doing DevOps or DevSecOps as sandwiches. But, you know, this is literally where we had to bring people up to speed and try and put it into things that they could understand. The process. And to me, this is the key. This is the bit that you succeed or fail on. Within the people, you know, you've got people problems and things and bringing people up and training, that's one thing. Technology, you can buy it. But if you get this process incorrect, you've just built your failure from the start. This is absolutely the key component. So first of all, permissions model. you have to separate out your engineers from the automation in terms of permissions. So the engineers go to GitLab, which is where we keep our code and has our pipelines and automations. And they go to Grafana. They don't anymore go to actually the back-end services. All of that is done via these robots, but actually in this case, basically, this is all based on GCP, which is what we use. So forgive me if you, but basically you need a credential in GCP to do something. Actually called Vault can generate those credentials for you. What that means is you get a short-lived set of credentials that allow you to do stuff. We connect that up to GitLab, which is where our automation is. So no longer do the people need credentials within the cloud to do anything. It's all controlled by Vault and it's all controlled by the automation. That's critical in my thinking, because what that means is you've separated out the people from doing stuff. That then allows you later on to have real automation, because now all your credentials are done by the robots. And the same way is getting the data back, getting the logs and the metrics and anything. The robots collect that, they send that, and then people are looking through Grafana at it. Still all exactly the same information, but what you're doing is you're removing the people credentials out of it, which means that when Fred is on holiday and his password expires, everything still works. This is critical to that democratization that I was talking about. Once you get to this stage, if you say that the first line support engineer can make the change, all they need is the credentials in here to make the change. They have to know nothing about the back end. Secondly, again, going back to that concept, small steps, but we deliberately went for continuous integration. So continuous integration, really, you can read a lot, there's books about it. This is my short definition. You have untested code, you have tested code ready to release, and you have tested code in production. That's it. How you get between the stages, slightly more complex, but continuous integration, your head branch, your main branch is always ready to go. And basically what's in production is what's at that head branch, the version number. And this is the stuff you're working on. So that gives you your continuous integration. What that maps to in terms of Git is its trunk-based development, short branches. And when I mean short, our standard is no more than 4 hours. So when you are working on an issue and creating a branch, I expect that branch to be gone in half a day. I mean, that's not always going to happen, but that's the expectation. And the idea is we are really, really doing short integrations. You're fixing it, you're working it. And to be honest, 90% of what you should be doing isn't in the code base. It's on the paper or the issue or whatever, where you're working out the problem, you're coming up with your solution. Turning it into code is the 10% bit. So, and the idea is this gives us this short, and therefore I don't care if one of these goes wrong because we roll back. And again, this is the key to actually increasing the speed and the flow. Keep it short, keep it simple. And then we come to continuous deployment and continuous delivery. And I always get them wrong way round. The main thing to know is that continuous delivery has a manual process in it. So over here, you'll see that code approval manual, and that's continuous delivery. In this one, basically, there's a manual process before it goes into production. So that sort of takes care of some of the test cases where they want to do external testing. Yep, so you put it into a staging system, and then it's approved. But what you're actually doing, what we're aiming for, and the ideal is continuous deployment, fully automated. And again, it's this idea of once it's in there, once it's ready to go, push it out into production. There's no reason to not do it. If there's a reason to not do it, your QA tests aren't working. What it actually means in practice is 90% of what we do is that top level, the code approval on the merge request. So you work on your change, and when you're ready to go, you approve the merge request. Once you approve that, from your test branch, is into production. This is then the workflow that describes how we deal with issues and tickets. Quick shorthand. Issue is feature request. So it's any feature request that comes in. Ticket is it's a broke fix. It used to work, it doesn't. That's how we define everything. If it used to work and it doesn't, it's a ticket. And everything else is an issue. You can spend a lot of time trying to define how you break up features and whether it's a feature. If it used to exist and it used to work and it doesn't, that's a ticket. Everything else is a feature. And that's how you then control the flow of work through the team. But apart from that distinction, once that distinction is made, and once they go into our GitLab as an issue, because that's what they call them, the workflow is exactly the same. And the workflow is to get it out into production as fast as we can. So what that means is your continuous integration is then controlled by your branch names. Your continuous deployment is controlled by your commit names. So your continuous integration is about the branches and the branch names. And those branch names dictate your route through the automation. The continuous deployment and continuous delivery is solely controlled by your commits. And what you put in that commits is how it then goes out. So when you basically, if you have an issue in GitLab, you get this lovely button that says create merge request and branch. We basically automatically put in issue dash whatever the name was. That's your branch and your merge request created. From then on in, the engineer is on his IDE or whatever, committing code. Every time you commit code, it kicks off the pipeline. The pipeline is doing the tests. When they've got what they want, be it a new bucket, fixed a name, or whatever is missing, and they're happy, they go to the merge request and they hit merge. Once they've hit merged, everything else is automated, because what will then happen. So let me go. Yeah. So this is literally how we define the jobs, and this is how you define the flow of work going through the jobs in your pipeline, which is looking at the branch name. So then when you get to the release point, there's a tool we use, which is called semantic release, because they were really inventive on those. And it literally matches what we've done is every commit name, and these are standards from the semantic commits, and a scope, it gets a bit more complicated, has a meaning in terms of the semantic level. It's a patch, it's a minor release, or it's a major release. And so what happens is you hit merge and your working branch is merged into the main branch. The main branch pipeline runs. The last job it does is the release job, where literally it goes through and reads the commits since the last time. It looks at what version number was there last, and then it pushes out the next version. It also writes the release notes and the change log. So the engineer doesn't even have to worry about doing the documentation. And so as soon as you that merge button, it's on its way to production. So this is a continuous delivery because there's a manual step. Someone has to hit the approve button, which is needed sometimes. And this is a continuous deployment where literally, so this is a Terraform provider update that came in sometime at night, whenever, goes through. And as you'll see, there's a whole bunch of tests that it passes. If it passes those tests, it gets merged into the main branch. The main branch runs, and then you'll see at the end there's the release job. The release job calculates what the next number is going to be, and then that branch is now pushed out. So that's probably 20 minutes, fully automated patches. So that's all of our Terraform providers, all of our code, anything you want to specify, updated every 6 hours. The only time we get involved is if it doesn't pass a test, or for some reason we want to manually review what's happened, and so we put that approve button on. This happens on approximately 600 pipelines every 6 hours, which means that all of our standard components, Terraform providers, Python, Java, is all automatically patched, even on weekends, and we're not there. And this is what your Git history looks like from your IDE. You just see bang, bang versions coming out. That saves probably 70% of our time of what an operations team is doing a lot of the time. It's just updating stuff. And at least twice, we've come in on a Monday morning, we've seen the CVE alert, we've looked at the logs, it's already been patched, even before we got the CSV, because the bot is going through the patches as released by companies and then applying them automatically. The way that we do this is, if you're Marvel fans, we have a mirror universe. So basically, we have a total duplicate of our cloud offering. And the main reason for that is a lot of the work we're doing involves that top level where we're actually making changes to how the public cloud works. So turning on policies, turning off policies. So it's not a thing you can test it there, but that's why we have a full duplicate. All of those test pipelines are running in our mirror universe, where as much as possible within whether a SaaS service gives us a sandbox or not, all of these changes are actually being run on live systems, but they are test systems. So we have a very good understanding of whether those are okay or whatever. And I think the main thing is that we take a sort of assured approach, or the fact that it's going to work. And if it doesn't work, because everything is a tagged release, we just deploy the last one back again. So we have a perfect rollback. Technology. This is the shortest section, really. You have lots of functional requirements. You know what you want it to do. In our case, it's run Terraform, it's build images, it's push out new infrastructure, it's configure things. Also in there, we have the security tests. We want it to do security updates. We want it to automatically patch. We want to manage secrets. So we basically came up with all the functional things we wanted to do. And then you go out into the marketplace, and then they say, hey, buy our thing. So what we're looking for, well, ethically acceptable, because that's what we really are. Easy to maintain. Cost, obviously. My principle, pick as few of these as possible. While you can have best of breed that are really good, you then got to integrate all of this stuff yourself. So, you know, what's the integration of this like? Yeah, available training, ongoing cost. How much does it cost you for the licenses? Still, my biggest bugbear with a lot of this stuff is it's targeted at very large businesses. It costs much more than we would want to pay. And then you put your little bits of what's the function, and this is the bit of stuff that's doing it. And in this case, you'll see that GitLab covers a lot of our stuff. So GitLab, HashiCorp Vault, that's the secrets management, but also gives us the ability to generate GCP keys, AWS keys, database keys. So you can offload a lot of your security that you want to use in a pipeline with short-term keys that are useless. So I think our GCP keys, they're valid for 2 hours. So even if it leaks by accident in the Git, in the repository, or whatever, it's useless. It's a new key every 2 hours. Infra cost. So one of the big things about cloud is runaway costs. Infra cost is an application that looks at Terraform code, and it will calculate what the cost is, approximately. And then you can set limits on that will stop the pipeline or require the pipeline to be approved. This is how you get away from the, I want a machine with 4,000 cores. What's also really good from our point of view is it also allows you to set which zones and regions things go in, which means that we can use that to basically drive people to the lowest carbon efficient zones. So you can't deploy to the dirty. Also, the other thing that infra cost we can do is we can check for labels. And if you're working in cloud, labels are the thing you have to have on everything if you want to do anything about cost, control, where is it, what is it, who owns it. Labels is absolutely key to that. So infra cost will check that everything is labeled before it goes into the cloud. Chef Inspect is the bit that happens afterwards. After it's deployed, we use Chef Inspect to do CIS checking. Does it have labels? Is it doing what we thought we wanted it to do? So it's the sort of the end checker. And then semantic release is the thing that actually looks at all the commit messages and works out what the next version number is. So we use Terraform, and the main reason we use Terraform is Terraform has lots of different providers. So it has not just AWS, GCP, Azure. It also has Cloudflare. So if you use Cloudflare, you can also code up all of your Cloudflare, which we do. It also has Okta. So if you use Okta as a thing, it can control that. What else do we use? It also has GitLab. So we can use GitLab with Terraform to control GitLab. It gets a bit circular. It also has a provider for Vault. So all of our Vault configurations is done via code as well. So there's lots of providers, which means that it's not just about deploying the GCP service, but the Cloudflare, the DNS, the Vault configurations. It's all in the code because we have different providers. Puppet is there because we have old Windows boxes, which we can't get rid of. And Puppet is still the best thing that we found for controlling old Windows boxes. So that keeps them all ship shape, because some of them are on ships. Ansible, again, as another sort of control mechanism, again, allows us to encode the configuration of things and then run a pipeline and push that out. And that means that your configurations are versioned and managed and trackable. Why is this changed? Oh, that person made the change. So your Git also becomes your audit. And if you're really nice to your auditors and buy them lots of donuts, they accept your Git changelog as a changelog in their reviews. Grafana. Grafana is the observability piece. We use Prometheus with Thanos, which isn't the Marvel one. Thanos is a collector for Prometheus collectors. And then that means that all of our metrics is in one single place, and we use Loki for the logs. So we have one interface that allows us to look at all of our metrics and logs and traces and cross-reference them as well, which is quite useful. And Renovate. Renovate is our update bot that, as I say, every 6 hours goes through the whole code base, Terraform code, Python code, whatever code, Docker images as well, whatever you want to do. And basically, we'll then create a merge request to do an update and send it through that automated process. So what the people do, the bot does, just it does it every 6 hours and doesn't seem to get bored. So what did we learn through that very quick? Make your automating system boring. No excitement. Your automation system is not the end goal here. Your automation system is the thing that delivers the thing which delivers the business value. So really, your automation system needs to be boring, the least cognitive load on the people supporting it. And how do you do so? Yeah, what do we learn? Secrets manager. You need it. If you've got pipelines, you need a secrets manager. Separate your permissions from your engineer permissions. Oh yes, in terms of moving from a physical data center to the cloud, you write a lot of transition stuff. We spent way too much time in it. I think we could have done a lot less work on that, because once it's done, it's useless. It doesn't really have any value. People accept change slowly. I think that's just a general thing. But you want to keep those engineers. If you're like us, where we can't afford to hire a new team in parallel or just fire them and hire new ones. And the other thing is those ops engineers are the ones who know how that critical system that you didn't know you had works. You know, that little machine in the background that beeps every now and again. It's those long-term ops engineers who know what it is, how it works, how to feed it, or whatever it is. So you don't want to lose that knowledge. So you want to bring them along. Resolution time gets a bit slower before it starts speeding up, because these engineers are learning on the job. And that's part of your management process then, is to make people understand that, make people accept that. Yeah, what you built in transition you don't need. You now have a whole lot of other stuff that needs maintenance. It needs assignment. It needs giving to people as a job to do. Continuous integration by itself is pointless. You need the continuous integration and the continuous deployment to actually get the benefits. Public cloud and SaaS change much faster than your on-prem system. If you didn't update your on-prem box for a year or two, you're fine. If you do not update your SaaS, your API is gone in 6 months. So you are now driven, your pipeline and your code and your infrastructure code has to deal with the speed of change of your providers now. It's not under your control anymore. Yeah, we should have dictated and enforced standards much, much earlier. Just in terms of coding up a deployment of a Helm chart. There's so many different ways of doing it. And what that means is that your engineers are spending cognitive load while looking at the pipeline that's going, oh, they're deploying the Helm chart via a Helm command in the pipeline. They're deploying the Helm chart via a Terraform command in the pipeline. They're deploying the Helm chart using a thing called Gimli in the pipeline. All 3 of those we've got. We should have been much more authoritative about standards, and then let the engineers battle it out with rubber swords in the backyard, because they all have their own particular thing. But from a management point of view, you want one, because that lowers the cognitive load when someone has to do something on it. So templates, standards, job catalogs. Yes, your jobs are all the same. put them in a repo, and then renovate, keeps the jobs up to date. Really good. So we basically have a set of jobs that build Docker images. So all of our pipelines that build Docker images use these standard job components. We changed from using Docker in Docker to Kenko. All we had to do was rewrite these jobs, rewrote the jobs. All of our pipelines changed the way they built images. So use your coding principles on your pipelines. Low context documentation. What do I mean by that? Explain everything to the last detail, because people don't know stuff. What you take as everyone should know, people don't. What that means is that it's much quicker to onboard people. It's much quicker to fix problems. And if you're in a security panic or an incident and you're reading the documentation and it says pull the left lever, yeah. If the security documentation says go to the server room, switch the lights on the left, you will see a lever. Please pull that. Yeah. When you're panicked or in a rush, you know, what does that mean? Oh, style guides. Style guides, very critical, again, lowering that barrier, increasing how quickly people can get stuff done. Yes, infrastructure code is not the same as application or data engineering. So once we got the system up and running, now other teams want to use it. So remember at that very beginning where I said we managed to hive off some of our work to other teams. Well, we've had to change and look at some of the ways that they work, which are slightly different to infrastructure as code. Yes, it's not about automation, is about encoding knowledge into that pipeline. It's not just about Q&Aing it, but it's putting in the guardrails that allow other people to use those pipelines to deploy the stuff. Your automated ecosystem is a new critical service product. Congratulations. And invest time in it and your automation ecosystem. So now we have to think about the classics. It's backups, it's disaster recovery, and it's business continuity. As I say, I was in the boat team for about 20 years. So this was a particularly nasty storm that we got caught in when one of our boats got washed out and forced onto the sands. So we had to go and recover it. And I was literally in a blow-up canoe in a creek with no paddle. So I had to nick someone's coal shovel to paddle my way to where I needed to get to before drying it off and giving it back. So I have literally been up the creek without a paddle. Pain points. Yeah, so I think, as I said, the ISE workflows is very particular to the SRE operations team. We made too many templates and had too many options for people. That confused them. We solved lots of problems that GitLab later on came and said, we now included that in our product, which gave us this point of where do we change to what they're doing? How does that affect the way we're doing stuff? Pipelines, they get slower the more stuff you put in them. How long should a pipeline be? I think that's a riddle. Yeah, we didn't really have a cleanup strategy for old pipelines, artifacts, and issues. How long do you keep this stuff? It's all building up in the system. We had too many people working on too many problems, not enough time to go around, to quote Genesis, nearly. So yeah, we still have those teams and lots of, in our team, we're still trying to deal with a lot of different things. Now we've got it, everyone wants it, but they don't want to change the way they work. So that's a sort of management problem. Learning curve is seen by a lot of operations people as too high, no matter how impressed they are with our automatic updates and how quickly we can do stuff. They sort of, oh, I can still do it quicker with ClickOps. That's a management problem, because as a management, you're going, no, that reintroduces way too many chances of misconfiguration, different configurations, all sorts of problems. So that's a management thing. Yeah, and now you have to maintain this ecosystem that you've built. Was it worth it? Yes, I cannot give you any data or figures. I've been looking back, but there's nothing I can compare how we were to how we are now. What I can say is definitely feels like less firefighting. It definitely feels like we're in control. We know how everything works. We can get it out there. When someone comes with a feature request that's like deploy a Mastodon server or something like that, it feels really easy. So we do much quicker turnaround on what I think would have been much more harder problems. But that fully automated process definitely saves us time, which we can invest in actually value add to the system. So version 2, what are we working on now? I think most of this is taking our templates that we made and our CI jobs and breaking them down into even further. And the idea is that we're going to have project templates, CI catalogs, which is a particular way that GitLab wants you to do their CI, and Terraform modules. So if you're going to deploy a bucket, a cloud service, or whatever, we're going to build a module that has all of our policy controls, all of our security controls built in. So we were a bit hesitant to go that route, but I think it's the next step in terms of it allows anyone then to deploy a secure object. We make sure the Terraform code deploys securely. We tell people to use it, which means that we can then increase the security. We're going to redefine the structure so that there's better permissions management via teams within the GitLab, because if you can run a pipeline, you can deploy code. So now we have more people, we have to figure out how to do that, and we've got some plans. Previously, we were doing Kubernetes authentication to Vault to understand what credentials it could get. I'm going to change that to JWT tokens because that matches much more this namespace model. And we basically splitting the teams into two, which is that one was maybe working on feature engineering, one's doing the support work. Even with those tribes, still sort of too much going on, try and focus it down a bit. That is it. And so are there any questions?
Okay, thank you so much, Joe, and thanks for everyone that's come along. I do have a couple of questions online, but we'll take one or two from the room while I just get myself ready for the ones that are online. So we've got Moses here.
Thank you very much for the great presentation. First of all, I'm curious about if you give us a bit of estimate of the size of the organization in that term, so like IP wise, so how many devices you provide and how you look after, and how many people work in the organization IT wise, and maybe in general as well.
Yeah.
So just
So we have in our team there's 12 engineers. In the department we have about 100 people. So but that's project managers, functional application managers, sort of first line support people. And this is at Greenpeace International. Each office will maybe have one or two sort of frontline help desk people who can give you computer, change the printer stuff. We look after all of the global systems. So think of your Salesforce, all of your infrastructure, so all of the internal networking, all of the mail routing.
how many people? 10,000 or
So that's
how many endpoint devices?
endpoint devices. It's probably around 7,000 sort of things. If you assume that it's about 3,500 people,
Yeah.
full time, it's not including contractors, not including volunteers, direct dialoguers.
About 7,000.
Yeah, so if you assume everyone has a phone and all that.
Yes, that's it. Just, you mentioned that in Ireland you have a data center.
We did, that's what we got out of.
Oh, yeah, so at the beginning you had a private cloud
Yes,
and you switched to somewhere,
yeah,
public cloud environment or, yeah.
so the idea was to get rid of the sort of physical noise. And
Yes.
in the beginning, we had 3 in each of the sort of
Yeah.
APAC in our regions. Then we consolidated it down to 1, and it was decided actually we just go total cloud and SaaS as
Maybe that was mentioned, maybe I overheard or I didn't hear. What was the cloud provider or is it?
Oh, this is GCP.
Thank you.
Okay, I'm going to take a couple of questions in the online audience because we've had a couple of good questions here. So apart from the automated testing, do you sometimes build in or always build in a human review for merge requests? Never or only sometimes?
We looked at merge requests, reviews, and we only do them if you think your project requires it. The reason is because we're a distributed team. If you had everyone reviewing merge requests, and we started out trying that, nothing got committed.
No.
Because there's not enough people to do the review. So we rely on the engineers to due diligence and we rely on the pipelines. You can request someone else to do a review if you just want to double check.
Yeah.
But there are like 1 or 2 projects where we have particular issues or things that we do a review, but no, we don't go for merge request reviews.
Okay, but you've got automated testing.
We've got the automated testing.
Then I presume people, they need to make sure if there's a new feature that they enhance the automated testing to cover that.
And so we work on that. If a deployment happens and then that deployment gets rolled back, then you're expected to write the test to stop that happening next time.
Yeah. That's a good, and I'll just take one other one from the online audience. So here we are. So Laura wanted to know, just wondering how you help people accept change a little bit easier, because it sounds like there's been a lot of change going on.
Yeah. How do you access? It's a carrot and stick. So the carrot is you can learn valuable skills that you can take to your next job.
Yeah.
We allow you to do as much training as you want.
Yeah.
Also, we have a philosophy of, given that we're an organization that can cease to exist at any point in time, we want every employee to have saleable skills that they can go to their next job with.
Okay.
Also, we take on a lot of graduates and new employees, again, for the same reason. We can't pay market rates. So we're quite happy to bring on people, give them experience, train them up. They go on, and if any luck, they infiltrate the large corporations as undercover greens. And the sick bit is sometimes you just have to say, no click ops. You're not doing it that way. And that's the management sort of end. And I think, yes, most people now accept this as a better way to do it.
Okay, there was a question about the duration for your transition, and I suspect it's one of these things as to, well, how do you know when you finished and all of that? But
so in that terms, I reckon it was 3 years from this is what we're going to do, 6 months of looking at what we already had in place, we're doing, what the marketplace had, then about a year of, okay, all new stuff goes through this system. And then once we'd started that, we then backfilled existing stuff. So within 3 years, everything was going through the system.
right. Okay, thanks for that. So anyone else in the room? Yeah.
What's the sort of diversity of the estate and sort of, is it a lot of SaaS applications? Are there like lots of sort of custom things, new things being built, legacy applications? What's the sort of breakdown there?
So we have sort of a lot of SaaS applications. We have purpose-built things. Our whole data thing is purpose-built. And then we have particular things. So we have internal applications that only make sense. You can't buy them off, particularly for the campaigning. We also have the ships. So on board the ships, we have physical hardware still, but also we have our own bespoke application that deals with TCP traffic over satellite, because there's loads of issues in that. And we also have a particular software that we've written, which deals with part of the radio operator's job is to manage who's on board, doing reports, all things like this, which we've again around stuff. And then also because the ships are constantly switching between satellite, wireless, and GSM, bespoke software around that. So we do bespoke software when there's nothing else, but otherwise we try and buy it in as an application or as a SaaS service.
Yeah, that was quite a mixture.
Yeah, it's a mixture.
Very good. Go on.
You mentioned you took a lot of graduates in, but that you don't do reviews. A lot of people use reviews to actually help train people up.
Yeah, I mean, as I say, they can request it. We don't enforce it, I suppose, and that's purely due to just speed, and we don't have enough people.
So you're talking about speed. I mean, because customers are always saying, "Yeah, we want it quicker." Who decided how fast things?
So what I decided, my decision, is that no new system, once really spec'd and understood, should take more than 2 weeks. And prior to that, you could be months buying a system, setting it up.
Is that because you're always doing different things and you need to?
It's because we are the technical team for everything. So literally we deal with such a wide variety of things that it can be, as I say, doing something on a ship, it can be doing something on a GCP, it can be configuring an identity access management.
So does that mean things don't necessarily live very long?
Oh no, they don't die. I mean, the only way they die is when we stomp up and down on them heavily, because part of our problem is everything keeps building up and we keep trying to say, who's using it? Oh, that one person. And say, well, is it really cost effective? So part of this is trying to get people to actually come off stuff so that we have less stuff to support.
Okay, I've got one, but I'll come back to you, Moses, but so I've got one more online, but an interesting one, and you might have touched on it. It's to do with, I think you talked about environmental impact, maybe carbon emissions and things like that. So the question is saying, what do you use to ensure that CI/CD pipelines and application deployments happen at regions or times when the carbon emissions are the least? How did we hear that right? Were you doing something to help?
Yeah, so what we do is we use InfraCost to deploy to particular carbon efficient regions. But that can be overridden because sometimes there's a legal requirement where something has to be in that particular region. So what we try and do is we identify those which we think are the most efficient.
Okay.
And then we try and get the people there. The other thing we do, and this is, I don't know if this works for other clouds, but in GCP, the way you can get discounts if you have certain things not things in a single region, so you can get a discount on those.
Okay.
So we try and put things into regions where we can then apply the best discounts.
Get the best pricing as well.
Yeah. I've not seen anything about different times, so
No.
So just purely in terms of the regions where things work.
Brilliant. Okay, thank you very much. I know Moses had his heart. Sam, did you have a?
Yeah, I have a question on the rollbacks because you did mention rolling back. How do you actually manage that? And have you actually looked at something called GitOps where your rollbacks and basically in the deployment is reversed? So it's basically when the environment pulls the configuration right and you push.
So we looked at it. It seems more complicated to me because of this pull push, whereas in ours, literally, because you now have a tag in your Git code, you just deploy to that tag. So literally, you go to the pipeline, you look at which version, and you just look at the tag, you select the tag, and the pipeline goes. And that's it.
Yeah, but then you have to manage which environment has which version, right? You have this problem. And then for rolling back when you need to roll back.
Yeah,
It's the rollback.
but because everything is decoupled, you're only rolling back the pipeline.
Right.
Yeah, so each pipeline is dealing with its own decoupled environment. So there's no dependencies, which means you just have to roll back that pipeline. Because we do a strict decoupling of services as well.
Right, and that brings them both the infrastructure as code, Terraform, and the application code.
Yeah.
At the same time.
So whatever is deployed in that version is what everything rolls back to. But we prefer to do what we call roll forward, which is fix the problem in the next release.
It's a really complex issue, rolling back, and as you say, fix forward tends to be the preferred approach, doesn't
Yeah.
it? Yeah. But, yeah, because it's not just things like maybe your Terraform definitions of your virtual machines and even versions of application code. If you've changed your database schema, or you've done some kind of operation on your
Yeah.
database, like migrating some data in from some other source or whatever, or some data conversion, you've really had it if you want to roll that back.
But then that's where we're in the semantic release numbers.
Yeah.
That's a break.
Yes.
That's a full version change on the
That's
most
hard.
left octave, at which point you cannot roll
And
back.
that's a precipice, you can't go back.
Yeah. So that's where the semantic version numbers actually indicates whether that's even possible.
Okay, and also things like API interfaces and versions of all of those.
Yeah.
But all, you know, there are strategies, but none of it's easy.
No,
No. Okay, I think.
On the sort of topic of those sort of major versions and changes and things like that, do you ever get other teams involved, external testing, pen testing, security testing, that kind of thing?
so we've done pen testing from externals. That tends to be when we're releasing very specific high risk items. So we did identity and access management, we got tested. We did an expenses claims system, we got pen tested. We're looking much more at doing more of that. However, I'm not sure pen testing is the way to go. I think bug bounty may be more interesting, because a pen test is a point in time. And if you're doing incremental releases, then actually your point in time is 5 minutes. So does the pen test have value at that point? Whereas a bug bounty program where you continually just ask people to go and kick it, you know, may have more value. So that's something I'm thinking about.
Let's put it correct. There are automated pen tests.
Sure.
So you can potentially do pen test every day.
Yeah, I mean, you can always do sort of various scanning tools
Sure,
and
yeah.
things.
I think the people that do pen testing manually would dispute that you can do automated pen testing. But you're absolutely right. You can do very clever scanning with dynamic application testing tools. You're absolutely right. Okay, can I just ask a question about you had the word sandbox environments, and I think you said for one of your slides you said you were using that for some of your SaaS applications. Can you just explain what that concept is?
So basically, because we want to encode everything in Terraform code, so like Okta, and we want to make a change, we have a test version of Okta that we do that change on first. And again, what this means is that we can do the test, put the tests in the pipeline, have it passed criteria, whatever that may be, which means again that we can have the fully automated stuff happening without affecting the production system. So if the test goes wrong, then it screws up the sandbox. Well, so what?
Yeah.
What that means is that everything that gets into production has been through as much as we can make it, real world test.
Yeah. But I think that's really good. And I've not seen many organizations do this. So yeah, it's hard because if you go to a SaaS service provider and you want to have a sandbox environment, I'll say that's absolutely fine. You've got to pay again.
Yeah.
Yeah. So you do get into those commercial challenges.
Yes.
The alternative is if you don't have it, how do you test things when you're working with a SaaS service provider? And it's really hard.
Yeah, and then things, that's where you might have the manual approvals because you don't have a sandbox, you have a live system.
Yeah.
And then quite frankly, you're losing 50% of the effectiveness of the automated testing, patching things that you get when you can do it that way.
And there are halfway houses. You don't necessarily have to replicate the whole SaaS environment. You might be able to subdivide it and so forth.
Yeah. So basically, within our organisation, what you didn't see is on that map of the original offices, we have a presence in Middle Earth. So we have a whole organisation full of elves, orcs, and dwarves, which exists. And that's one of the ways that we get round on the testing environment as well.
Brilliant.
Are
Okay,
you-
we take one more question and then, yeah, go on.
No,
Lucas.
not,
Yeah,
not
it's okay.
for the last one. No.
It's okay. Does anyone else have a question they'd like to ask? Oh, go on, Moses. Yeah.
No,
Oh, okay, that's fine. Okay. Well, look, thank you so much again, Joe. Thanks for coming along.